Hey, everybody, and welcome back to another episode of the Ruby Rogues podcast. This week on our panel, we have Dave Kimura.
Hey, everyone.
I'm Charles Max Wood from Top End Devs. Wanted to give a quick shout out about Rails Remote Conf. Just go to railsremoteconf.com. I'll make sure that links through the right place. We also have a special guest this week, and that's Ben Taylor. Ben, do you want to say hello and introduce yourself?
G'day, how you going? I'm Ben, a software engineer from Australia. Mostly work in education software, but today I'll be talking about WebAssembly.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com. Yeah, that ought to be fun. Maybe we'll have you on JavaScript Jabber too. We haven't talked about WebAssembly for a while. But to kind of kick this off, you wrote an article on Dev2 that walks through how to run Ruby in your Ruby snippets in your browser.
Yeah.
And that was interesting. So I'm curious. Yeah. What did you do?
Yeah, that's a good question. What did I do? So I'm pretty interested in education and particularly programming education. And so I've been looking at different ways to get code running in the browser for like 10 years. And a long time ago, we had mscripten, which was a technique for compiling programs like C and C++ programs to JavaScript. Mm-hmm. And more recently, we've got a technique called WebAssembly. And the tooling for WebAssembly is just getting better and better every year. And like a start of this year, a person called Kate made a bunch of changes to Ruby, to C Ruby, that were part of a bigger mission to get Ruby running in WebAssembly. And I was thinking about how could I get Ruby running in WebAssembly, and I went and had a look, and it turned out that all those changes had been merged. And this was around January of this year. And I had a look, and Ruby ran in WebAssembly, and the toolkit that I was using, which is called, it's from a group. The tool is called webassembly.sh. It's a tool I'm basing my stuff off, but the program I use is called the WebAssembly Package Manager, and it allows you to install WebAssembly binaries as packages really easily. And Kate had put Ruby on the WebAssembly Package Manager, and that meant that my program, which is called Runo, could just run it. And so I just installed it, and then it ran client-side in the browser. It was like a few hours of work in total for me, but all the backing was there, from a bunch of other people.
Nice. So I kind of want to just walk through this a little bit. I mean, I read your article, but it was pretty short.
Yeah.
But yeah, so effectively, well, let's start with how this all works, right? So,
yep.
So Ruby, I guess, compiles to WebAssembly.
Yeah.
Is it the VM that actually compiles to WebAssembly, or?
So it's a bit hard to understand. There's this standard that is pretty new. It's a web standard, and it's called WebAssembly System Interface, WASI.
Okay.
And you can kind of think of that as like Linux. So when you're compiling Ruby, it compiles to a bunch of different targets. So like you get a binary for Ruby for Mac OS, you get one for Linux, you get one for Windows. And then WASI is a different target that is kind of like one of those. But instead of being an operating system, it's just kind of like a fake API. And that API defines some really simple stuff like how to access files. And when you compile to that target, you get a WebAssembly binary, and then when you run that WebAssembly binary, you have to provide those function calls. So you, as a consumer of the binary can't do anything until you let it access files or until you let it access sockets and things like this. And so that's the way that Ruby is able to compile to WebAssembly. It has this kind of like operating system emulation layer.
Okay. So what would be some of the actual use cases of having a Ruby based in the browser? So WebAssembly or anything like that. What is that going to give us that we do not currently have with server rendered HTML and client side JavaScript and that kind of stuff?
Yeah,
front end on Rails, right?
Absolutely. It's a good question. And front end on Rails, maybe that's the future. There's a lot of weight in it as well. The Ruby binary is like 11 meg gzipped. And so if we were to serve our front end on Rails, it'd be a bit of a nightmare, much worse than serving React. You'd have to serve that Ruby binary and then also serve all of your Ruby code. The
Nothing's
use case
worse than serving React, right, Dave?
For a user of like the Ruby binary, a web browser use case is not particularly compelling. For me, what I find useful is I can use it for education purposes.
Right.
So I can run Ruby in the browser. I can test whether a student's code is working. I can get them to run their code, and that requires no installation. So that's a really cool use case. But that's not really the use case that people were imagining when they were inventing this stuff like WASI. One of the really interesting parts of WASI is that it's fully portable. So if you think about like a Linux binary of Ruby, that can only be run on Linux, or a Mac OS binary can only be run on Mac OS. A WASI binary can be run on any system that implements the WASI API. And this is kind of a really neat idea because it means that if there's a new CPU architecture out there, they just need to implement the WASI API and then they're able to run binaries. So when the M1 came out, there were all these problems because people couldn't get compiled versions of all of their favorite programming languages or libraries. And if they're in WebAssembly, then they can just run by default and they don't have to be compiled to your particular target. And this can be very useful for server-side situations rather than just client-side web browser stuff.
I gotcha. Yeah. I did say there's nothing worse than loading React, but this feels a little bit like Java.
Yeah, it does feel a little bit like Java. I mean, this was the dream of the Java VM, but it kind of, the Java approach never really took off. What we're seeing with WebAssembly is because it's a web standard, as a target, it kind of is a lot more compelling than the Java virtual machine.
Yeah, I can see this having some, not necessarily the Ruby aspect, just WebAssembly in general, having some real world applications outside of running your Ruby interpreter or that kind of stuff. But anything that requires like actual hardware processing power that you are wanting to take off of the server just because of the latency on the server generating or calculating and then sending back to the user. But if the user had a more powerful machine, then you would have a lot more capability. So any kind of like AutoCAD work, if, Autodesk or somebody made a online AutoCAD version that could really take power or make use of 3D rendering and that kind of stuff, then I can see WebAssembly having some really powerful use cases and stuff. But for web development and Ruby aspect side of things, I mean, maybe there will be some better machine learning libraries that get integrated with the WebAssembly down the road.
Yeah, it's so in terms of client side, I worked with someone who used to call client side free compute, which I really like as an idea. It's being able to run Ruby in the browser, I think is kind of interesting. It means that if you've got some library that you're super dependent on that only exists in Ruby, you can chuck it up there and you can have it running client side, and that might be useful to you. I think the portability of the WebAssembly binaries with this WASI standard is is interesting beyond that, you've got like Cloudflare workers can now work with Ruby. Previously, they couldn't. Fastly has a similar worker standard. These are different ways to run programs, not just at a server level, but like at the edge of a CDN network. And a lot of these use WebAssembly as a way to run code. And with Ruby running in WebAssembly, now you can use Ruby for that. And I think that's really interesting.
So, but you still have to take the hit on the package size, correct?
So what I mean is, this is server-side Ruby running on the edge. So edge networks are like CDN networks. And so you've got a server running, say, I live in Melbourne. Most web servers are in the US. That's like a 200, 300 millisecond latency. But a CDN network, the edge might be a few blocks from me. And so suddenly you're bringing that latency right down to like a few milliseconds.
Right. But with this approach, you're basically trading off the latency for the package size and the bandwidth usage.
No, what I mean is literally the Ruby would be running server side, but it's using WebAssembly to run it.
Oh, okay.
Yeah. So because WebAssembly is portable, it's way easier to run. And a lot of these CDN edge networks run WebAssembly rather than running real binaries. Yeah. Does that make sense?
Yeah, that makes sense. That was not a connection my brain was making. So so Ruby running in WebAssembly means we now have this new use case. Like we can run Ruby on edge networks. There's also like people talk about it. It's not particularly interesting to me, but a lot of cryptocurrencies use WebAssembly as a standard for running code. This means if you're willing to package, the 11 meg Ruby binary in your cryptocurrency, I don't really understand how that works. You could run Ruby in your blockchain thingy. I mean, that's so cool. Blockchain.
Yeah, so I don't really understand that use case, but it is there. Another thing I think about is like, sometimes you'll be installing a package and that package will install another package and that package will install another package. And then you're watching your package manager compiling Python for some reason. And you're like, why is this happening to me? If all of those steps were using WebAssembly, your binary wouldn't have to be built. It's just already there, already built to WebAssembly. And that could run on your machine, like on your laptop.
That makes sense. So we're talking portability. I kind of imagined WebAssembly being something that, hey, I'm just going to stick this on the web page and it's going to magic some Ruby up on the browser, right? So is that not something you can do then?
Yeah, so absolutely you can do that. I got a bit distracted by portability. I think the portability story is really interesting. But yeah, absolutely. You can run Ruby in the web browser. The new Try Ruby page, which is try.ruby-lang.org, has the real C-Ruby 3.2 running on it, which is pretty cool. So you can try Ruby and it's cool. Real Ruby. Like it's not some custom Ruby that's been built for the browser. It's the like real Ruby binary. And that also means that as Ruby gets updated, those WebAssembly compilation versions of Ruby will also get updated. And so we'll see web browser as a target for Ruby being updated as frequently as any other operating system.
So I haven't done too much research on WebAssembly, but do you really just kind of mount it as a component like within your HTML and then that initializes, pulls down the binaries, executes within the browser? And so if so, are you going to be able to communicate back to other WebAssembly components on the page or other components on your page, as well as sending information really just back and forth?
Yeah, so you don't quite do it with the HTML, you do it with the JavaScript API, but it's basically like that. You can instantiate the WebAssembly runtime with a URL, you let it boot up, and then it provides a bunch of exports, and you provide a bunch of imports. And so the exports that the binary provides, you can call into, and the imports that the binary requires allow you to provide information to the binary. So you can think about it kind of like a WebAssembly binary can't do anything unless you provide it with the imports or unless you use those exports. The binary is kind of by default sandboxed.
Yeah, and my understanding of WebAssembly is that it's not directly interchangeable with JavaScript. So you kind of have to, they do interplay. You can call one from the other and vice versa, but it's not like a direct, hey, these are all running on the same VM, because it turns out that the WebAssembly VM and the JavaScript VM are separate, and JavaScript actually can't compile the WebAssembly.
Yeah, it's like, it's a bit of a, like, that boundary can be a bit rough, because you're running system binaries. Stuff like strings is tricky. Like, you would think that passing a string to some library would be easy mode, but strings have to exist in memory, and they have to be encoded in some format. The JavaScript default is to encode in UTF-16, which isn't particularly common. And so you've got kind of like, you've got your JavaScript stuff and you've got your WebAssembly stuff, and then the boundary can be a bit tricky.
Yeah. We've talked a little bit about this on JavaScript Jabber. I'll see if I can link some of the relevant episodes into the show notes. But yeah, so I'm a little curious too what this means for things like Opal, right? Because Opal kind of, it was kind of a halfway measure that compiled to JavaScript.
Yeah, so there's lots of other strategies for running Ruby on the web, and some of these strategies are much more appropriate for the web. Like I said before, this huge page weight of a WebAssembly binary, Ruby is big, like 11 meg, is going to be slow. If what you need is compatibility with real Ruby, which for an education use case for me, that's exactly what I want. I want real Ruby running in the browser. I don't want people to learn some kind of slightly different Ruby. Then you're going to take that hit. But if you don't really care about how your Ruby runtime works, and if it could be a bit different to real standard Ruby, then something like Opal is still going to work for you.
That makes sense. And it has all the support for things like WebSockets and stuff like that. So if I did want to load it into the page, right?
Yeah. You mean Opal, or you mean Ruby? Ruby running in WASI?
Yeah.
Yeah. Well, so if you run Ruby and WASI in WASM, like in WebAssembly, you kind of get nothing by default. So the WebAssembly system interface doesn't provide much more than files and sockets. And so if you wanted to have Ruby connect to the internet via your WebAssembly runtime, you'd have to implement files and sockets, which would be a bit of a nightmare.
Okay.
Yeah. So it's a bit of a niche use case, but once it's implemented once, you can run any programming language. So my website, Rano, it's a tool for teaching programming languages, currently supports Ruby, Python, JavaScript, C, C++, and SQL. And the way it works is that I implement that WASI interface once, and then I can run any of these programming language binaries. So adding Ruby to it was really easy because Ruby supports the WebAssembly system interface now.
I want to argue about SQL being a programming language, so no, that makes sense. It's really interesting. So, and you said this runs on kind of edge systems that are out there on CDNs. Do all the CDNs support this, or are there certain ones that you found that work?
Yeah, so probably for WebAssembly, I think Fastly is one that's the most into WebAssembly, and they do things the most WebAssembly way. Right. Cloudflare, I think they prefer it to be a JavaScript runtime rather than a WebAssembly binary, but maybe that's changing. So I know with Cloudflare, a lot of the time they run other programming languages by having those programming languages compile to JavaScript, which is a bit tricky. And then you end up with these edge cases where the JavaScript doesn't quite implement things exactly the same as the way Ruby does. And you kind of have to write Ruby as if it's JavaScript.
Right. I'm just trying to think through what the implications for this are. One thing that I'm wondering about too, though, is with the page size and things like that. Do we foresee Ruby ever implementing some kind of optimization that way, or maybe the build tools for WASI, WASM implementing some kind of optimization that way?
Yeah, and that might be a strategy for reducing the size of these binaries. People also talk about having a garbage collector built into WebAssembly And so then Ruby wouldn't need to package its own garbage collector with it. That might bring the weight of the binary down.
Mm-hmm.
It's hard to tell how much of the binary size is necessary and how much of it is optional packages. So there might be the possibility of tree shaking out a bunch of stuff from Ruby.
I was going to ask that next.
Yeah. So it's hard to know like how small we could get Ruby. There's like Ruby's an old piece of software now. There's a lot in there, and maybe it doesn't need to be as big as it is.
Yeah. What does the performance on this look like? Right. If I'm running WASI on the browser end, I don't know what I would expect, but if I was going to run this versus like a compiled C version on my Linux or Mac distribution, how do they compare?
There's definitely a performance overhead. The intention of WebAssembly is to be very low level, but it's an emulator effectively, and there's not a one-to-one correspondence between the WebAssembly calls and the calls that you would have on your CPU. And so about 20 to 30% performance hit anytime you're running something in WebAssembly.
Gotcha. So you wouldn't run your Rails app on it. You would use it for other things.
Yeah, absolutely. There's interesting stuff with WebAssembly. I was talking about portability, and security is another really interesting part of this story. With a WebAssembly binary, you provide it with what functions it can do. And so if you have a situation where security is very important, you're running a Rails app and it has access to data that, you want to keep secure, and you have external dependencies that you need to run. If you run them in WebAssembly, you can guarantee that those external dependencies don't get access to anything you haven't given them access to.
Oh, interesting. Okay.
You could guarantee that kind of like at the binary level, like where you're running the binary, rather than having to guarantee it at kind of like a system level by using something like Docker.
Mm-hmm.
So that's not so much a use case for compiling something with Ruby to WebAssembly, but rather running WebAssembly from Ruby. So you might, let's say, ImageMagick was a huge issue years ago. Everyone had to run ImageMagick on their server, and ImageMagick is a binary piece of software. It would crash all the time. It had a bunch of other issues. Running that with WebAssembly instead of running the direct binary would mean you'd have a lot more control over what it was doing.
Mm-hmm. Hey, folks, I'm here with JD from Raygun. JD, we were talking just a second ago about empathy, and it seems like a common concept within the programming community. And yet, when we're building features for customers, a lot of times we call it done when it passes CI, deploys, and doesn't give us errors. And that really doesn't seem very empathetic when it comes to our customers, because we're not looking at what they're doing. Do you have thoughts on this?
Yeah, absolutely. I mean, at the end of the day, until your code actually hits the customer, you don't really know if it's any good. Everybody uses things in so many different weird and wonderful ways. You can only really debug in production.
I've been there. It's done. It's not done. Oh, crap. It's not done. I got to go fix it. Now it's done.
Yeah, absolutely. And when we see things like error reports flowing into Raygun,
right,
a lot of the time it's things where you just kind of go, oh, that was a configuration that as a developer, I didn't think could exist, but actually here's an example. And so it's connecting that code to customer and your development team through to real users and their experiences, which to your point, builds real empathy, and the best software teams care a lot about how their customers are experiencing their software.
Right. It's kind of the feedback from the app, but it's also kind of this meta feedback. As we do better, we tend to get less of this negative input back from our customer, which really does reflect empathy.
Yeah, absolutely. And I also think, to your point earlier about CI/CD pipelines, like we've done an amazing amount of work as an industry to automate getting to prod really fast. But if you really want to go super fast, you need to close that loop with real-time feedback from prod back to the dev team. And that allows them to do things like fail forward and just really leverage that investment in CI/CD, and it can turn into a real superpower.
Yep, absolutely. So I'm going to encourage you folks, set up your CI/CD, but then go sign up for Raygun. They'll actually give you a free trial, and you can get it at raygun.com. So when you have this set up on Runo and you've installed it to Runo, you're running it on your CDN, correct?
So the CDN use case is kind of more like, I think, something that's interesting. It's not something I'm using.
Okay.
So Yeah, so Runo, the way it works is I've got a WebAssembly, like a WASI layer, and then I've got a terminal emulator, and that terminal emulator connects to the WASI layer. And then behind the WASI layer, I've got the WebAssembly binary for a programming language. And so Runo loads up. You've got a program in there in Ruby. You click run. Runo then downloads the Ruby binary and starts Ruby running on your browser. And then it runs the code using that emulator.
Makes sense.
I think the thing that's really interesting about Runo, that I kind of designed it for, is this idea of running snippets of programming language on any website. Mm-hmm. So Runo runs client side, and that means that you don't have to run a server that runs other people's code. And so if you're writing an education platform, or if you're just writing blog posts, you can embed Ruby snippets in those blog posts using Runo. I've got two strategies for embedding, one with iframes, and the other using a node package.
Gotcha. How do you account for things like Ruby gems then?
Yeah, that's the big question. So currently Runo can't do Ruby gems. Technically, it's possible. Ruby gems just exist on the file system, and Ruby loads them up when it's running. So I could download those Ruby gems and then put them on the file system. But then if the Ruby gems have any dependencies that aren't just Ruby, then I'm going to have to figure out a way to run those dependencies. So it's that's where kind of like the iceberg is with running stuff in the browser, is like that whole network of every other thing that, your program depends on. But I think there's some like interesting use cases for this also around stuff like documentation. I would love to see runnable snippets inside documentation.
Mm-hmm. Yeah, that would be amazing. But yeah, I can imagine, some of the utility gems that we have out there. Yeah, no problem. But then you pull in like Nokogiri that has to compile against the C library.
Yeah. And what's interesting there is I'm running C in the browser because someone, I forget their name, figured out a way to compile LLVM to WebAssembly. And so my C runner takes LLVM, it takes the compiled LLVM, which is compiled to WebAssembly. Mm-hmm. It puts C code into that WebAssembly binary. That WebAssembly binary, then running in the browser, compiles that C code to WebAssembly, and then I run that C code. So it's like this multi-layered WebAssembly series of actions. But what that means is that something like Nokogiri, which needs to be compiled, could technically compile in the browser using LLVM, which is wild.
Interesting. I'm trying to think through the implications there.
I think like the power here is that as we keep adding to WebAssembly, you're going to see your full stack eventually just be able to run in the browser. And it's not going to be some trick where it's a x86 emulator or something running a virtual machine. It'll really be running in the browser.
Right.
That'll be interesting. Especially if they start shipping WebAssembly binaries for Nokogiri like they started doing in a recent-ish release for x86, ARM, and that kind of stuff. So that'd be cool.
Oh, yeah, that could be interesting too, right? Where you have the target for like a Nokogiri target that doesn't require the C library and instead runs on WebAssembly. Sorry, I cut you off, Dave.
Yeah, no, but that should be interesting. So how secure is WebAssembly from a developer perspective? So let's say if I create some kind of Ruby on Rails framework for WebAssembly, but I still need a centralized database that I'm going to store all the user data, but all the processing power, all the business logic is being done in the WebAssembly, and it makes a connection back to my database or through some kind of proxy. Are the credentials or authentication or keys, whatever it's going to use within WebAssembly, reversible?
Yeah, so the story with WebAssembly is that the binary can only do what you give it access to. So like the binary can only access functions that you give to the binary. So if you think about like a normal Ruby program that you run on your web server, you've got a Rails server, you install a gem. If that gem decides it wants to access the internet, it probably can.
Mhm.
you can't really do much about it. It just goes and does it. With WebAssembly, you tell each binary that you run what it's allowed to access by providing it functions that it calls. So if you installed in an imaginary world where you can compile gems to WebAssembly, if you called a WebAssembly gem, and you didn't provide it with internet access, it wouldn't be able to access the internet. But if you had compiled your whole application to WebAssembly, and then you went and supplied that WebAssembly binary with access to your database, it's going to be able to access your database, and so there is still that idea that you can always shoot your own foot, and tools are trying to make that harder and harder over time, but you still tend to be able to.
Yeah, I can see if, the compiled WebAssembly binary running on the client's browser, you may not inherently be able to see what's going on, like it communicating back to the database, because that's all happening behind the executable. But if you were to put any kind of man in the middle, or if you were to put any kind of proxy in between to sniff out the packets, then you could essentially reverse engineer the encryption keys or authentication keys that you've compiled into the binary to communicate back to the database server or the database proxy. And that could essentially be a security issue that people may not normally think of.
Yeah. So if you're compiling, let's say you're compiling keys to your AWS or whatever into a WebAssembly binary and then serving that binary to your users, it's the same as if you were putting it in your JavaScript and serving that JavaScript to your users. That key is there. It's just a bit harder to read.
Yeah, but the flip side is that there are systems out there that seem to have robust security that do some of this stuff like Firebase and things like that. Mm-hmm. So those kinds of security exist, but it may not exist in the same way that we do from our Rails server to our database server, since there's nothing that's kind of sitting in between the front end in the way that the Rails server does.
Yeah. So you've got the same security problems that you've always had. And this is an extra tool that you can reach for, especially if you have, say, binaries or programming language tools that you don't trust. You could use WebAssembly to run those. This would be extremely useful if, say, you wanted to implement your own serverless runtime. So let's say you've decided you're going to invent new Heroku, but you're doing it serverless and you want to write it all in Ruby. You could reach for WebAssembly as a tool for running customers' code.
Right. That makes sense. But on the other end, yeah, you're going to handle your security the way that we handle security in the browser, not the way you're going to handle it on a provisioned server or provisioned Docker container or something like that.
Yeah. You'd probably end up with both those layers. The kind of neat thing is Docker as a system is providing a whole emulated computer. It's a whole computer in there, right. which is just, it's quite strange as an idea. We run our, tiny little web server, but to run that, we have to, spin up effectively an entire computer.
Right. I'm going to run my server on my server.
Yeah. Yeah, absolutely. And what WebAssembly is targeting instead is just the binary runtime, not the whole computer. And so if you think of it as a kind of attack surface, the attack surface for WebAssembly is very small, whereas for a Docker container, it's quite large because it's a whole computer.
Right.
I'm just waiting for popular websites like YouTube or something to make Bitcoin mining package. They'll just start mining Bitcoins on your
that's the danger with WebAssembly. People have been talking about this for ages. As soon as people were able to compile stuff like Bitcoin miners to web browsers, people were using it to, dodgily make money out of their users. Something that's actually interesting, you mentioned YouTube. There's a neat use case of WebAssembly where you encode images or video on the client side rather than the server side. So encoding images or encoding video is a really expensive task, and it's expensive if you have to do it on your server. But why not get the client to do it before they send their file to you? And then you get a saving in two ways. You don't have to do the computation, and then it's also smaller over the wire. And so I forget which software it is. One of the forum softwares implemented this system where they compress your images with WebAssembly before they send it to the server. And so the user puts their image, into upload, and instead of uploading the raw image file, we re-encode the image file, compress it, and then upload it, saving you a bit of bandwidth.
Yeah, I don't know if it would really say bandwidth if you are doing adaptive bitrate streaming, meaning that you have to do several different transcodings for a 4K video to 1080p, 720 and stuff. So you're still going to be sitting a lot, but definitely on the server side, reducing that computation size, especially on something in the scale of YouTube, would be really amazing. For YouTube at least, because then they're going to be able to do a lot more without the additional infrastructure. Because having done the video transcoding on the server side before, it's really taxing, especially if you're a smaller shop and you want to do, video uploads to your transcoding. It can really mess with your systems a bit, especially when things start to auto scale because you uploaded a new video. And then you're like, but I don't need it to auto scale because I don't have a lot of traffic right now. But if I were to take care of all that on the client side without having to know the ins and outs of what video transcoding is, then that could be a real use case. That's really interesting.
Yeah. What's the Linux package for doing transcoding of video?
FFmpeg.
Yeah, FFmpeg. FFmpeg has been compiled to WebAssembly. And so, so you can run FFmpeg in the browser. So if you were doing this, if you were creating your own video website and you wanted to not have to transcode the video yourself in the back end, you could use FFmpeg from the front end and compress that video before it comes to your server.
Oh no, that is awesome.
Yeah, that sounds really nice.
Yeah, and these sorts of people are doing all of this kind of stuff, getting as many different libraries as possible, compiling to WebAssembly. And the more and more of this stuff we can run in a portable way, the more we can run it on the front end. But it also means we can run it on the back end in a more reliable way using WebAssembly rather than having to compile that binary yourself.
Yeah. And just thinking like PDF conversions and stuff before you have to do most of that on the server side. If you're not using a package like Prawn where it kind of re-implements everything, if you're using Wicked PDF, which uses WK-HTML to PDF under the hood, you had to have that binary installed on the server. But if you could get a WebAssembly package for that, you just pass the HTML to that WebAssembly component. It then generates a PDF and sends it, or just downloads it because it's already generated on the client side. That would save the hassle of having to change your Docker infrastructure or bring in these extra packages just for that functionality.
Yeah. Is WK to HTML, is that running WebKit?
I don't know.
Yeah. I think that there used to be this technique of doing PDFs where you would run WebKit to generate the PDF, which is funny because then you'd be running a web browser in your web browser to generate a PDF.
Yeah, I think it is using WebKit.
Yeah, it wouldn't shock me. I think most PDFs, when you break them down, are XML files or have some XML component to them.
It's a funny world, and probably we're going to end up in this world where we're running web browsers in our web browsers so that, someone can do some arcane magic. It's kind of cool.
Yeah, well, running web browsers in your apps is a thing that's been done for a long, long time, where effectively you embed some kind of web view and then you run a local web server to serve up the information for that. I know that several mobile apps do that on iOS, and others work in similar ways. And then you've got like the Ionics and stuff that actually the whole app is in a web view.
Yeah.
Anyway.
Hey, it's what the hybrid Turbo Native does.
Yeah.
Or Turbo iOS. You just have that WebKit view and then some Turbo bindings that can leverage some of the native APIs of Android or iOS to interact with the website.
Yep.
And to bring this back to WebAssembly, if you are doing those sorts of techniques, hybrid techniques, and you want to use some system binary, if that system binary is compiled to WebAssembly, you can just do that from a web view.
Ooh, that's interesting. So there's been a lot of talk, and I don't know if you know the answer to this question, but a couple things connected in my head. So there are a lot of things that you are restricted from effectively uploading to your iOS apps, right? You can't just put anything you want in your iOS app. So if I need a compiled binary for a particular thing that I want to do on the iOS app, I have to find some kind of native thing that already exists or write it myself. And what I'm wondering is if I can get those libraries in some kind of WebAssembly API, then it just depends on the browser engine on iOS, which is Safari. Do you know if Safari actually supports that kind of a thing? Like, what's
so
the mobile
Safari,
support for WASM?
Yeah, Safari will run WebAssembly. My website Runo runs on iOS on Safari. So if you wanted to run Ruby inside your iOS app, you could do that via a web view and the WebAssembly compiled version of Ruby.
Nice. I'm going to make Tim Cook cry. Anyway, yeah, that's really cool because it opens up some of these other possibilities where maybe not Ruby, but maybe a C library or something that compiles to WASM or FFmpeg or something else, right? Where it's like, okay, I'm going to pull in the FFmpeg package and I'm going to do the FFmpeg stuff on the phone, right?
Yeah. And it's also got a really interesting story with web applications that you might download and save on your phone. So if you've got a web application and it uses WebAssembly to run some system calls, if you're saving that application to your phone and it saves all of those resources locally so they can be run offline, you can do a kind of a native-like app experience that was all running in the web browser.
Yeah, we're getting into progressive web app area here. But yeah, also interesting.
Yeah, absolutely.
Cool. So what's kind of the next stage for this technology as far as our capability of running Ruby on your browser?
So for me, for Runo, I think what I'd love to get to is being able to run Ruby gems in the browser. I think a lot of people would love, from a learning and education point of view, would love to be able to run Ruby snippets wherever they want. If you could have on your blog any little piece of Ruby that you've written, if you could run that just in the browser on your blog, that'd be great for running demos. I think a lot of people would find that really useful. That's the next step that I want to get to with Runo.
Yeah, for that documentation end too, right? It's, hey, here's Ruby with my library or my gem or whatever installed. Here you can play with it, right? Without me having to go and actually kind of rewrite it in WASM or whatever.
Yeah, and that documentation example I think is really interesting because if you have documentation that is kind of hard to understand, often you have to like get it all running on your system to try it out. And that's something that's really great about Ruby. You know, it's very easy to open up IRB or open up a debugger and like get things running. But if it was just there and you could edit the arguments to a function and see what the output was, that'd be so much easier. And it'd be so much easier to find exactly, you know, the method or function call that you needed.
Yeah. I'm also imagining a CI/CD that runs all my tests in the browser.
Yeah, totally plausible. Like GitHub is trying out all this stuff with running VS Code in the browser. And I think we'll probably see more and more of your app able to run in the browser. So, you know, eventually you might just open up your GitHub repo, click edit your file, it runs your tests, and you commit it right there without, having to set up a local development environment.
Yeah, I'm assuming that they've compiled Git to WebAssembly. So
I have no idea. Probably. It would be relatively easy to.
So from there, yeah, you know, if you have a Git repo and you want to interact with the code in the repo, I'm just seeing a whole bunch of things open up here, right?
Yeah.
Just depending on what you can do with local storage.
Yeah, I think it's that portability story. It seems kind of like, oh, cool, you can run stuff in other places. But then once you start like thinking that through and thinking about all the use cases, like it actually like creates this wild combination of ideas, not just like this one new thing. It's the new things combined together to enable stuff that you'd never thought of before.
Yep, makes sense. Dave, was there anything else you wanted to bring up?
No, I'm still just infatuated by the FFmpeg.
Right. Mind blown.
It really is. Because, I mean, that really opens up a lot of possibilities.
Yeah, I've seen some things that look a whole lot like I think there's a version of Photoshop or something like it that runs in the browsers. You can do all kinds of, I know Canva does it, but Canva does it, I think, through JavaScript. But
so Figma, have you used Figma before? It's really popular for designers. Figma's all written in WebAssembly.
There you
so
go.
Figma's written in C++ and then compiled to WebAssembly. And that's it's a full, more like a Illustrator than a Photoshop, but it's, there in the browser.
Yeah, I guess I'm imagining then, those kinds of tools also being able to be opened up, right? Where you could actually, there's one for podcasting too. I'm trying to remember what it's called, but there's an audio editor that you edit in your browser. And I always wondered, is it talking to some backend and saying, snip here, this, that, and the other. But yeah, I wonder if it's written in WebAssembly and just manages the audio file in memory in local storage on your, or not even in memory on the file system in local storage on your browser. And then as you go, it uploads the version that you're working with.
Yeah, very well could be. Yeah.
Cool. Just all kinds of neat stuff that you could go do with this stuff.
Yeah, absolutely. And I think the story is, we've been talking a lot about the browser. I think the story is just as compelling on the back end with Ruby. You can use WebAssembly from Ruby. You can call out to these WebAssembly binaries from Ruby. And you could have the same binary running client side and server side and have that, no knowledge that it's going to execute the exact same at both places.
Nice. All right. Well, let's just leave it there. Hopefully we melted some brains here. Let's do some picks.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
Dave, do you want to start us off with picks?
Yeah, so just one pick. It's a company called TouchstoneHomeProducts.com. And they make a lot of different things. But if you've ever seen one of those like TVs that kind of lift out of furniture kind of things, I bought one of the TV lift mechanisms that I can use on a big screen TV that I have on a cart. And so I sometimes need it a bit higher or a bit lower. And so I didn't want to have to lift a 100-pound TV and readjust it where it goes on the mobile mount. So I got one that has a linear actuator built into it. So this TV lift mechanism, it actually works really well. It's pretty stable, and I'm very happy with it.
Nice. I know I have 2 linear actuators in my standing desk. So is that a standing TV?
Yes, it basically is.
Very cool. Now I want one. I don't need one. Maybe I can convince my wife I need one. Anyway.
I love the idea of hiding a TV somewhere in your furniture, and then having it just like pop out from nowhere.
Yeah, I've seen them built into bed, like the footboard of your bed. And so the little door opens up and it comes up out of and those are pretty cool, right? It's like, okay, we're going to put the TV away now. I've also seen them where they drop down out of the ceiling.
Yeah.
Oh, that's cool.
Actuator.
Yeah, because TVs can be kind of ugly. I mean, nowadays they're pretty good, but like if you got a big TV in your room, it takes up a lot of space. If you could hide that, that's cool.
Yeah, I mean, we have one in our bedroom and it's just mounted on the wall. But yeah, if you want to put other things on your wall or you don't have the kind of wall space you need or want for that computer for that TV. Yeah. I can kind of see that. I'm going to throw out some more picks. My first pick, I always pick a game. And the game that I'm going to pick is, and this is something, so I'm going to have a handful of picks because we went on a road trip with my wife and kids. But this game is Fantastic Beasts. What was it? Perilous Pursuit. And it's a cooperative game, which isn't always my most favoritist kind of game because a lot of times the cooperative games, sometimes you all kind of work together and sometimes you play a 4-player cooperative game where 3 of you are watching one person play the game. And anyway, This one, I could see kind of going that way, but for the most part, it was fun and there was plenty of interaction and we were just kind of having a low key game night. But Fantastic Beasts, you can imagine it's from the Harry Potter movie series, right? You're all working together to capture all of the beasts that came out of Newt Scamander's case. And you each play one of the characters from the movie. And you have different abilities, basically. Everybody has the same abilities, but each of you have different capabilities within that ability, right? So you may be better at distracting the beast than at capturing it, right? And so what you do is you roll dice, and then you stack the dice to activate the abilities, and then use those abilities to capture the beasts. And it's relatively simple. Board Game Geek weights it at 1.83. A 1 is a really simple game, and a 2 is kind of a casual gamer game. So yeah, everybody could kind of sit and play it. It says it's for ages 8 plus, and I could kind of see kids at that age being able to pick the game up. So anyway, it's kind of a fun one if you're into Harry Potter and you want kind of a different game mechanics. Like, some of the elements reminded me vaguely of some other game elements in other games, which is pretty common if you play a lot of board games. But there were a few ways that it went together that was kind of unique. And so it was kind of fun to sit down and figure it out. The only complaint I really have about the game is that I don't see how you could basically not win it every time. So, and that was just my experience, and maybe there's a way to make it harder, but anyway. So yeah, but it was fun, and it was fun to just sit around and yeah.
Yeah, I really like those sorts of cooperative board games. It sounds like it's not your favorite when you're working together, but some of them, it's like actually really exciting when you lose, because then you really want to play it again, you know?
Yeah. We have pretty much every version of Pandemic ever made, right? And
yeah, I love Pandemic.
There are a few of those that really kind of make you go, all right, how do we do this? So yeah, and that's a fun one. And we've also played all the Pandemic Legacies, which is kind of fun because it introduces a new element every time you play it.
Yeah, I really like that. Legacy version where it kind of gets harder or easier depending on how you play. If you don't play well, it gets a bit easier. If you play really well, it gets harder. Yeah.
Right. Yep. So that's kind of where those are at. I am going to do a quick shout out about Rails Remote Conf. If you want to speak, the CFP is still open. If you want to come, you can buy a ticket. If you want to do a workshop, I am going to share some of the money with you. So, just go fill in the CFP. Let me know what you want to do. DHH is kicking it off with an hour-long Q&A. And so it should be really fun. It's going to be at the end of September. So anyway, looking forward to that. And, then I'm looking at getting the meetups together this next month. So if you want to speak at the meetup, if you want to sponsor the meetups will be free. The conferences, you have to buy a ticket, but the meetups are free. They're going to be low key. We're going to have some mechanism for you to sit down at a virtual table and chat with people. So it should be fun. And then as far as the road trip went, there are a few things I want to shout out about. Now, one of them was, and this is more of a pick to just remind people, to go connect with your roots, right? So, the family reunion we had was in Nauvoo, Illinois. And if you're not familiar with the history of Nauvoo, Illinois, it's where members of the Church of Jesus Christ of Latter-day Saints gathered after they were basically chased out of Missouri. And so they settled on the banks of the Mississippi River, built a city, built a temple. A lot of my ancestors came through there, and they stayed there for several years until they got chased out of Illinois. And then they crossed the western United States to Utah, what is now Utah, Salt Lake City. And so, a lot of my ancestors after that lived and settled in Utah. So anyway, and so, yeah, that's where I'm from. I live here in Utah. But anyway, it was terrific because we got to kind of walk around and kind of see how the city was laid out, stuff like that. There are still historic buildings there, so you can go and check it out. And they have like a blacksmith shop and a brick kiln and gunsmith shop. John Browning, he actually invented a whole bunch of technologies that are still used in firearms today. And he had his shop there in Nauvoo. And so you can kind of go walk through it and see the different things that he used and did in the gun shop. They had a tinsmith shop. They had a print shop. Joseph Smith who founded the church was martyred out there. And so you can go see the jail where he was killed and the where he lived. And anyway, so it was really, really terrific. So if you're interested in kind of that historical context, or you just kind of want to go see how they made things with hand tools, when I like my power tools, I really appreciate them now. But if you want to kind of go see how they did it back in the day, it's a terrific place to go visit. The other picks that I have, so when we got out there, the check engine light came on my car. And one of the things that I have invested in that I just leave in the car is I have a little OBD2 reader for the car, and it connects to my phone. So it just sets up its own Wi-Fi network. You get on the network, and then you can use an app to connect to the thing, and it reads the codes off your car, which is really convenient. And I think it cost me like $20. And so that's really, really handy, as opposed to the big bulky things with the big fat cord that you have to fight in order to, anyway. So yeah, I'm going to pick that. We have this basket that slides into the trailer hitch on our car. You just, you pull the ball. I can't remember what it's called, but you pull the big beam with the ball out, and then you just slide this into it, and it works great. So anyway, and it's a lot more pleasant than trying to throw things in a basket on top of your car. And so that's what we did, because we have an 8-passenger vehicle and 7 people in the family. So it doesn't leave a whole lot of room for luggage, and the trunk space in our vehicle isn't very big. So that was awesome. And I think we got that on Amazon for $150. So I don't know what the prices on these are now, because we've had them for a while, but anyway, those made the trip more pleasant. And then the other thing that we had was the old cigarette lighter power thing, the round thing that you plug the power in your car to charge your phone. I got one of those. I got something that plugs into it that provides 3 of those outlets and 4 USB charging ports. And so we were able to charge all of our devices driving out, driving back, which was a lifesaver with a 6-year-old whose iPad only lasted half the drive before we had to charge it. So anyway, it made for a really, really, really pleasant trip. So I'm going to pick all that stuff, and we'll let Ben do some picks. Ben.
Yeah. Absolutely.
What do you want to shout out about?
So I'm obsessed with this book at the moment called Anathem. It's by Neil Stephenson. I'm on my 2nd consecutive read. It's this concept. Neil Stephenson's famous for doing really deep sci-fi, and Anathem is from this concept. He was pitched this idea of a 1,000,000-year clock. So how do you make a clock that runs for 1,000,000 years? And Anathem is what he imagined the clock would be. And so the system has these layers, and each layer in the system opens at a different interval of time. And so there's a day gate, a year gate, a decade gate, a 100-year gate, and a 1,000-year gate. And in each layer of this clock, different people live. And each of these layers is kind of like a different length of time since those people have been outside. And the people within those layers study and learn about maths and physics, but they're not tainted by this outside world. And it's just this fascinating idea. And he explores it in this massive way, in this kind of totally fake, but kind of similar to Earth world, with all these weird words and kind of strange concepts. It ties together a lot of philosophy of science ideas and physics and, multiverse kind of stuff. Super interesting book. And that's like my number 1 pick for today.
Very cool. Now, one last question. If people want to connect with you or see what you're working on these days, where do they find you?
So best place is Twitter. I'm Tay Benlor, TAYBNLOR on Twitter. And if you want to check out my project for running code in the browser, it's called Runno, RUNNO.dev, runno.dev.
Awesome. All right. We're going to go ahead and wrap it up here.
Bandwidth for
Thanks
this
for coming.
segment
This
is
was
provided
really
by
fun.
CacheFly, the world's fastest CDN.
All right. Till next
Deliver
time,
your
folks.
content fast with CacheFly. Visit CacheFly.com to learn more.